session. In this session, you are going to learn Chapter 6, Specification and Abstraction. Content of this video is, among the algorithmic design technique, you are going to learn about abstraction. What are the algorithmic design techniques? Or specification, abstraction, composition and decomposition. So in the previous video, you learnt about specification and the formats and how to specify an algorithm. In this video, you are going to learn about abstraction. Abstraction is the process of ignoring or hiding irrelevant details and modeling a problem only by its essential features. As I told already, if a person is driving a car, the essential thing like the procedure of a brake, accelerator and the gear and the steering are important. If he press the gear, if he press the accelerator, he will know that the speed is going to increase, but he doesn't know the mechanism behind it, how the engine is increasing the speed. So that is said to be irrelevant detail. So the abstraction give only the important or essential features which is required for a person. That means a simple word is a car driver need not be a mechanic. That means a driver can know only the essential things. He doesn't need to be a mechanic to know all the details behind the working process. So abstraction is the most effective mental tool used for managing complexity. So if we do not abstract a problem adequately, that means if you didn't abstract a problem to the essential thing, we may deal with unnecessary details and complicate the solution. So this abstraction concept is very important for real-time problem to have only the essential feature by the process of ignoring or hiding the irrelevant details. As we know, specification abstract the problem by the properties of the inputs and the desired input-output relationship. So we know what is input, what is going to be the input-output relationship if we are writing a specification for a given question or a problem. We recognize the properties essential for solving the problem and ignore the unnecessary details. So in a specification, it will give all the details. Among the details also, the important things only taken care. That is abstraction. And then we have going to learn about two concepts, that is state and functions. State means it in algorithms, the state of a computation is abstracted by a set of variables. That means the variable is going to say the state of a problem or state of that process. Functions. When an algorithm is very complex, we can decompose it into functions and abstract each functions by its specification. As we know that there are two more techniques. One is composition and decomposition. So function is coming under decomposition. In the book, abstraction. So to ride a bicycle, it is sufficient to understand the functioning of a pedal, handlebar, brakes and bell. As a rider, we model a bicycle by these four features. A bicycle has a lot of more details which the rider can ignore. So this concept is said to be the abstraction. So here they are saying about two problems. One is a map. Map is an abstraction. How means the map is an abstraction of things we find on the ground. We do not represent every detail on the ground. The map maker picks out the details what we need to know. So different maps are drawn from different purpose and so use different abstractions. They hide or represent different features. A road map is designed for drivers. They do not usually worry about hills, so most hills are ignored. So likewise, so they are given one example for abstraction. So map is a abstraction tool. In medicine, different specialists works with the different abstractions of human body, and orthopedician work with the abstraction of skeleton system. So here also they will taken care for a special for the essential thing. If he is a cardiologist, he will take care of the heart, like that. The problem is divided. Not here, the division is not important, how it is taken care, that means where the importance is stressed, that is abstraction. So we have going to learn about the state and the function. So state is the basic and important abstraction. Computational process have state. A computational process starts with an initial state. That means the problem's initial state. As actions are performed, that the process are done, its state changes. That means the value in the variable changes. It ends with the final state. State of the process is abstracted by a set of variables in algorithm. The state at any point of execution is simply the value of the variable at that point. So it's a 2 mark. State is any point of execution is simply the values of the variables at that point. So in each process, the state of the variable changes. They are given an example like chocolate bars. That means a rectangular chocolate bar is divided squares by horizontally and vertical grooves. That means they are going to cut it. We wish to break the bars into individual squares. You can imagine your Cadbury chocolate. To start with, we have the whole of the bar as a single piece. A cut is made by choosing a piece and breaking it along one of its grooves. So imagine the chocolate bars like this. So we have to cut the piece with the shape of like this. So it has to be cut horizontally or vertically to get the complete square or rectangle. So start with, we have a whole bar of single piece. A cut is made by choosing a piece and breaking it along one of its grooves. Okay, so that's a cut divides the piece into two. How many cuts are needed to break the bars into individual squares? So the number of pieces and the number of cuts are essential variables of the problem. We will represent them by two variables, P for pieces and C for cut. Respectively, the state of the process is abstracted by the two variables P and C. So this is essential variables or essential details. Irrelevant detail means the sequence of cuts that have been made and the shape and size of the resulting pieces are irrelevant. So likewise, we have to ignore some of the details. They have given another example program, that is a goat, grass and the wolf problem. So it's an interesting problem. I hope many of them have learned this in your small classes. It's like a riddle, but anyhow, we'll see once again. The problem involves four individuals. That means the farmer, grass, the wolf and the goat, each at one of the two sides of the river. This means that we can represent the state of four variables and each of them has one of the two values. Let us name the variables as farmer, goat, grass, wolf. 4. The variables are and the possible values are L and R. That means left side and the right side. One bank of the river to the next bank of the river. A value of L means at the left side and the value of R means at the right side. Since the boat is always with the farmer, it is not important to introduce a variable to represent the position. So first, the farmer, goat, grass, wolf, all the four are in the left side. Our goal is to make all the four to come in the right side. But there is a specification. That means, what is the specification? The goat cannot be left alone with the grass. So if goat equal to grass, then farmer equal to goat. So this is the condition to be followed. So I'll explain this. We'll see this problem as a video. Consider that in one side of the river, there is a farmer and a wolf, goat, and the grass. So the target is all the 4 has to come to the next bank. The condition is the goat and the wolf, or the goat and the grass should not be left alone, or else they will eat one another, right? Wolf will, that means the farmer can carry only one in the boat. If wolf and goat are alone, the wolf will eat the goat. If the goat and the grass are alone, the goat will eat the grass. So the farmer has to use some technique. So what's the technique? He has to take one. So first he is taking goat to the next bank. That means next side of the river. Now he is taking the grass. Now he taking the goat to the next place. He is leaving the goat there and taking the wolf to the next side of the river. Now he is going to take the goat. So finally, by number of sequence steps, he reached the next side. The number of steps you are going to learn in the next chapter. So if you understand the problem, you can write the steps by yourself. So here, they want to insist 2 things. One is assignment state. It's an important 3-mark question. The variables are named boxes to store values. What is a variable? Variables are named boxes to store the value in a problem. Assignment statement is used to store a value in a variable. So first point, we need variables to store the value. The process of storing the value in the variable is said to be the assignment statement. It is written with the variable on the left side of the assignment operator and a value on the right side. Yes, here this equal, colon equal is the assignment operator in algorithm. While writing the program, it will change, but understand here, colon equal is the operator and it is the assignment operator in the algorithm. Left side is the variable, right side is the value. When this assignment is executed, the value on the right side is stored in the variable on the left side. That means m colon equal to 2. The value of 2 is stored in the variable m. So m is a variable or the stored place. It will have a memory allocation in the computer, and in that memory allocation, the value 2 is stored. If the variable already has a value stored in it, assignment changes its value to the value of the right side. That means, for example, you think that m is having 0 at starting place, and now m equal to 2 means the 0 is replaced with 2. The old value of the variable is lost. Right side of the assignment can be expression. That means the right side can be a single value or an expression like this, m equal to m plus 3. So m plus 3 is said to be expression and the final value is stored in the left side variable. So what is the meaning here means, first we told that m equal to 2, right? So m is having 2. Now we are saying 2m plus 3. M means 2. So 2 plus 3, 5. This value is stored in the same location. So 2 is replaced with 5. Can you see here? So 2 is replaced with 5. Then 2 sides of the assignment statements are separated by the symbol colon equal is known to be the assignment operator. Note that the assignment operator is not an equality operator. So it is again a 2-mark question. What is not equality? What is equality operator? Equality that means there is a difference between colon equal and equal. Assignment does not state a mathematical equality of a variable. Equality means comparing the left side and right side. Assignment means storing the right side variable to the left side variable. Okay. Assignment means comparing the left side and right side. Left side and right side means this v equal to e means I am asking whether the value in the v is equal to the value in the e. The assignment statement can be in a single line. That means v1, v2, v3 colon equal to e1, e2, e3. That means v1 is having the value of e1, v2 is having the value of e2, and v3 is having the value of e3. They are explaining this with an example. See here, m comma n colon equal to 2 comma 5. That means this 2, first one is going to store in the first variable m, and 5 second is going to be stored in the second one. That is m is 2, n is 5. Then m plus 3, n minus 1. So what is in m2? So 2 plus 3, this should be changed to 5. Here already 5 is here, so 5 minus 1, 4. The final result of m is 5 and n is 4. You got the point here? Sometimes it is an applied question for your 3 mark also. So abstraction concept is very easy, and we have covered this chapter 6. Here they have given some applied questions. Try to solve it. That's all for this session. Thank you, children. Have a good day.